a general theme, is there's places in the plan that dictate where you put things in the profile. Okay, let me show you with the cul-de-sac and the elbow. So let's go back to the drawing. I'm going to go back to my drawing. Let me get rid of some of the stuff here. Okay, so in order to do this, you have to draw your edge of pavement. Your gutter line, you need that drafted everywhere. Okay, I didn't do mine, but I will. I'll show you a couple things. So where's the last place I have a cul-de-sac? Well, I think it's right here on the right of way. From here to here. There's my standard 20, and then it gets wider. Okay, so there's where my cul-de-sac starts. Right? So everything above this line is standard 20 meters wide. Everything down in this area is the cul-de-sac. So there's the entrance to the cul-de-sac right there. Right? That's the first point on the cul-de-sac. The elbow, not quite, but there is a point where the elbow comes out, comes back, and so on. So I'm just going to temporarily draw something. Again, I don't want to give away the geometry, right? So somewhere over here, I don't know where, depends on where you drew it, is the last time you have a standard 20 meter right of way. Somewhere, and then it gets wider. I didn't draw it, right? So somewhere between here, and let me draw another one here. Okay, so you drew a bulge here. I'm not going to draw it. I don't want to show that to you. I want you to try it. So somewhere between here and here is where the pavement gets wider on the outside. Okay, so that's the beginning and that's the end. So you need to know where this station is. Again, this is not where yours is. This is just an example. So that's the last, so from the station valve, that's the last time you have a typical 20, then you go around the curve, and that's the last time you have a non-standard, then you're back to the typical 20, and so on. So you need to identify these points in the plan as station values in the profile. Now there's a couple of ways of doing it. You could draw a line from the intersection of this label to the intersection of where that happens, right? List that line, right? 1865 and add it to 60, so it's 60, 1865. You could do that, right? But I'm not going to get lost in the numbers. There's better procedures. So here's the procedure. Again, I'm just guessing where these zones are, right? You'll know exactly after you draw them. So if we'll go back to my sketch here, right? You have to draw exactly where your standard 20 ends, right? Here's my 20 meters standard width, right? That's the last time I have a standard 20, and this is the first time my standard 20 comes back, right? So if you draw this correctly, then you'll know exactly where this station and this station is in the plan view, okay? And I don't want to give it away, so I'm just going to guess, right? You'll have 2 points. This is the last time you have a typical 20, and this is the first time you have a typical 20 back. In between here and here is what I call the zone, the elbow, okay? So if I want to find that station value, here's a handy tool. I'm going to draw a point, AutoCAD point, P-O-I-N-T, point. This is AutoCAD. And I'm going to snap to that intersection, center line, and that point where the zone starts. So there's an AutoCAD point. Draw another one at the other side. Right? This is the end, intersection. There's another AutoCAD point. Now, if this point is hard to see, there's two commands you want to explore. One of them is called PD mode. PD mode. This is all AutoCAD. PD mode. Right now I have it set to 2. If I change it to 3, watch what happens to what the point looks like. It's like an AutoCAD style. It looks like an X. If I put number 2, it looks like a cross. If I put number 6, no, not 6. If I use 2, 5, oh, sorry, 3, 5, it looks like a cross with a circle in it. It's just the style for the AutoCAD point. So if you don't see anything, PD mode, I would change it, PD mode, I would change it to either 2 or 3, right? A cross or an X. If you still can't see it, then there's the size, PD size. And change it to something a little bit bigger, right? So 0, you're not going to see anything necessarily. Actually, 0 is, if you regen the screen, it's always the same size, so don't use 0. Give it an absolute number. So change the PD size to either 2 or 3. 3, 5, change the size. 6, 4, right? So PD mode, I would suggest using a 2 or a 3. And then PD size, I would suggest anything bigger than 2 or 3. So you can change and manipulate the size and the size of the AutoCAD point. That's not simple. So put a point where you know the zone starts and ends, right? And then there's another 2 over here, right? I'm going to have a point here, intersection, and I'm going to have another point here, right? And it's going to be, I'm just going to guess, somewhere there's an edge of asphalt here, right? It's going to be here, but offset 0.3, and you put your point there, and then you don't need that line anymore, right? You just want to show the gutter line, not the asphalt point, right? So again, my points, these 4 points I just drew, I'm just guessing. You'll know where those points are exactly after you draw all this geometry correctly, based on the standard for an elbow and a crescent, elbow and a cul-de-sac. Okay? This is just for demonstration purposes. Once you identify in plan where those zones begin and end, right? So this is the last time we have a standard 20. This is the first time we have a standard 20 back. And then from here all the way to here, in my case, I'm going to design my profile at 0.5%. And then from here to here, I'm going to design it at 125, right? So 0.5%, 1.5, 0.5%, 1.25, just like the sketch, right? I'm identifying where I start and end my elbow, and then where I start and end my cul-de-sac. Okay, so if I want to draw those points from the plan view to the profile, there's a handy tool for it. So if you click on it, right, 1, 2, I'm going to do all 4 at once. You can do one at a time. It's up to you. So I'm going to do all 4 at once. So if I know these points are in the plan, I want to identify them in the profile. I'm going to go to, so I've selected them. You can see the blue dots, right? I've selected them. I go to my profile. So under Home tab, I go to my profile view. And there's a command called project points to profile view. So once they're selected, you start this function. And you go over to your profile and you touch the grid. So I'm going to touch the grid. And then it's going to give you this dialog box. Now those points in the plan are AutoCAD points. And I snapped the locations where the elevation is 0. See, the elevations are all 0? If I say OK, so this is what not to do. Watch what happens if I say OK. Look at my grid. See how big it got? Because my design is up at 100 and something, but those points are at elevation 0. So now I've got these points way down here, and my kind of design range elevations is way up here. So don't do that. Here's a trick. Let's do this again. Same function. And do something a little smarter. So I'm going to go back to here. Choose the points. These are the points I want to project to my profile. I'm going to start the profile project objects to profile view. I'm going to pick the grid. And instead of accepting those zeros, I'm going to go to elevation options, select all, and temporarily I'm going to say, you know what, get your elevations from the existing ground. They'll be close to my surface, right? Elevation from existing ground. And now it changes the elevation. So instead of 0, which is what's in the plan, it's going to get the station values from the alignment, but it's going to get the elevations from the existing ground. So watch what happens now. They're all in range, and they should all be kind of touching the existing ground. And then you don't get that huge grid that I just showed. Okay, so I'm going to delete this. Okay. So there are the zones for the beginning and the end of the elbow, and the beginning and the end of the cul-de-sac. Right? So everybody needs to do this. The elevations are wrong, but the stations are correct. Okay? The last thing we need to do now is this thing. Remember this trick? Oops, this trick here. I want to start here, I want to go down and then up. I need to know where this station is. I also need to know where this station is, but this one is critical. Here's the trick. Again, I'm going to draw something very, very crudely. So if I had a polyline, so if you drew your arcs correctly here, remember, draw your arc here, 7.5. You use the fillet command. You remember this? Right, if you finished your intersection design, and I'm just going to draw a line. So if this was touching, this circle was touching. And I'm just trying to create some geometry. This is wrong, but I just want to show you something that would look like what you did. Okay, So if you did your intersection design, these curves would exist, right? And this would be broken here. Okay, so forget what's happening here. You're going to have a curve. Your gutter line comes and then it curves away. Your gutter line comes and then it curves away. Because you're existing, right, this is not exact, okay, it's an approximation. Once these are drafted correctly, mine are not, they are not perfect. Yours should be exactly where they're supposed to be, okay, based on the discussion we had last week. Once you draw these two, these points are not going to be exactly across the street from each other, right? If I draw a line from this end point, perpendicular to center, if I draw a line from this end point, perpendicular to center, they're not going to be exactly across the street from each other. Why? Because the existing edge of asphalt is not an exact line. It's a bunch of points connected in sequence, right? The low point wants to be, of these two ends, of these two curve ends, the one that's closest to the inside of the subdivision. So not this one, this one. That's my low point station right here, the one further in. The only time these are directly across the street from each other is if you're designing a road at 90 degrees to a new road. So two new roads at 90 degrees, these will be exactly across the street from each other. But when you're dealing with an existing road and maybe the angle between this center line and this center line are not exactly 90 degrees, then you're always going to get a bit of a shift. Okay? It's not going to be perfect. Of the two, the one closer to the inside of the subdivision, the one furthest away from the intersection dictates. So you want to put a point right there. Okay? Now it's hard to see if you don't draw those two lines. So what I do is I put a point in at these ends, put another point here, and I project these two. When I project these two, it'll actually figure out the station value perpendicular to center. Okay? So at a glance in plane, you can't tell which is further away from the intersection. I know it's this one. But if I put the point here and here, not on the center line, watch what happens when I project it. So I'm going to project both. Enter, I'm going to go to the grid view, somewhere near the intersection. And again, the elevation is 0, so I'm going to say temporarily put it on the existing ground, because it's really the station I'm after. Say OK. And now, if you look at the profile, you'll see, oh, this one is further away from the intersection than this one, so I'm going to throw this one away. That's my station for the low point. It's easier to see in profile. If you just project both, you can quickly see here which one is further away. It doesn't matter which side of the road, whichever one is furthest away. If you want to draw the two lines that I had before, right, if you want to draw a line from this end point perpendicular to center, or this end point perpendicular to center, if you want to draw these and decide, yeah, it's this one, I won't even worry about that, and then just project the one, you can do that. But that's a lot more work. Right? So to avoid drawing these two lines, I just project both of these into the profile, and then you can, at a glance in the profile, see, oh yeah, this one's too close to the intersection. That's my station for the low point. So now I have the station for this position right here, the low point. And then I need the edge of asphalt here. You can either get it from the profile, it's right there, or you can project it. You can actually put a point on center. Point at the intersection of the edge of asphalt and the center line. That's my first design elevation to match existing. Project that point, and it shouldn't be a surprise that it falls exactly here. Click here, change this, get your elevation from the existing ground surface. When I say OK, it should land right here. There's my first point. So there's the station. 1, 2, 3, 4, 5, 6 station values. Elevations are garbage. 1, 2, 3, 4, 5, 6 station values. If you use this technique, you never get lost in the numbers. I don't have to write down the station value. I don't have to, remember what the elevation. Just draw the points in the plan and project them to the profile. And now you have all the design stations. The elevations are wrong, but you have all the design stations. And that's the technique I expect you to use. So again, if you draw any of this wrong on assignment 2, it's going to put these points in the wrong spot in the profile. Okay? So again, you can proceed, and then if you do have an error with this, if you make a mistake here, then you can always adjust these. Just, you know, oh, I drew this in the wrong spot, right? It turned out that this was actually over here. Well, just put a point over here, and watch this. If I move this point in the plan view, it actually moves it in the profile view because it's projected. It's dynamically linked. So if you have to redraw the elbow, just keep this point that if you decide to start now. Once you move this, watch. Let me put it way over here. Right now it's way over here. If I move it back, it'll be closer to here. It's dynamically linked because it's constantly projected. Right, and that moves it closer. So if you do make a mistake on your gutter line, you can just project the point to the new position and then adjust your profile. I'll show you how to do that. Does everybody understand this technique of projection? It's a really simple tool, and you don't have to remember the number of the station or the elevation of the surface. You draw stuff, you're using geometry, and you're leveraging the function to take a point in plan and show you where it is in the profile. Very simple tool. Okay? And we're going to use that tool many, many times, but this is one of them. Now we go back to something you did in highways. In highways, you put in a profile. Remember, in highways, I'll give you some more nightmares. Remember, in highways, you had an existing ground that looked something like this. It was kind of low, high in the middle, and then back down. And then you went uphill, uphill, downhill, downhill, and you put in vertical curves. You remember this? When you drew that green profile, that's what we have to do next. Okay? But it looks like this. It's blue line. So here's how you do that. Okay, so we're going to go to Profile, Create by Layout. This is a bit of review from highways, Create by Layout. You're going to pick the grid. I want to do my design in here. I'm going to give it a name. I use the repeat street X, that's the horizontal street name, and then I say finish ground FG. When I say OK, I get this dialog box. You might recognize this from highways. And then it's not the first button, but the second button. And now you want to set your O snaps before you start. Set your O snap to clear all node, because all those points are nodes. Say OK. And now I'm just going to connect the dots, starting at the low chainage, 0, and work my way upstream, up change, right? From low chainage to high change. So I'm going to use this second button, PDI. And we're going to snap from this node to this node, to this node, to this node, to this node, to this node. Okay? And there's my profile. The stations are what I want, the elevations are garbage. So how do I design it? I go back to this table. You might recognize this from highways as well, profile grid. And you'll see the list of station elevation, station elevation, station elevation. The stations are all correct, the elevations are all wrong. They're existing, I need to propose them. So then I work in this grade out column. And I put in the slopes. Start at the beginning and work your way to the end. So what's the first slope supposed to be? Anybody remember? That's my profile. Negative 0.5. So, and you can actually, this is dynamic. As I change the numbers, it's going to redraw. Right, so watch here. So this one here should be negative 0.5. So there's my low point right there. What's the next one? Positive 0.5. So you don't need the plus sign, so 0.5. So there's my first stretch, 0.5% up to where the elbow starts. Then the slope in the elbow. Remember the slope in the elbow right there. Back to the grid. Slope in the elbow is positive 1.5. And notice the grid is adjusting because I'm adding data that's higher than the limit that I had before. Then from there, I go all the way to the entrance to the cul-de-sac at the minimum slope, 0.5%, 0.5. And then from there, I go to the end of the cul-de-sac at 1.25. Remember the design, right? 1.25. 1.25. And that's my design. Now the negative sign doesn't show up, but it is downhill. Negative 0.5, positive 0.5, positive 1.5, positive 0.5, positive 1.25. If I design the center at 1.5, my gutter is going to be at least 1%. If I design the center at 1.25, my gutter in the cul-de-sac will be at least 1%. So when you look at this at a glance, you might be wondering, what was this designer thinking? Why is he not using 0.5% everywhere? Like, why change the slope at these locations? Why are these locations critical? Why are they key? Why are they using that PVI location? Why are these stations where they are? The station values in the design profile are actually key locations in the plan, where your elbows, where your cul-de-sacs, and where your intersection low points are. So the points in the plan dictate the location of your profile points, station values. The elevations now are taken care of. If I go back to that grid, right? If I change the slope, it's actually updating the elevation. So the proposed station elevation, station elevation, station elevation. The elevations are changing when I change the slope. So as I update the slope, I'm updating the elevation, right? So if I change this to 2%, the last number is going to go up. Right? So it's adjusting the slope as we go. That's the design profile. This is the first step in assignment 3. There's a lot more to do in assignment 3, but this is the first step. So if you can get this done for next week, I know you're working on your assignment. Some of you are done, so that's why I want to introduce this now. Or if you hand it in on Friday and you got nothing to do on the weekend, you can start doing this. Okay? So you have to have assignment 1 done. You need the edge of pavement. You got to know your bulb and your crescent location. And draw those points in the plan. Project them to the profile, connect the dots with the profile design using this tool here, and then go to the grid and change the slopes based on this design concept. This is the concept. All of you will use these same numbers, but you'll have different station locations, different elevations, depending on which site, which topo you were assigned. But at a glance, they'll all look the same. That's your homework for next week. If you can get that done for next Tuesday, when I see you next, then we can proceed to cross-section. We're going to look at the assembly with sub-assemblies, and then we're going to build a corridor. And the corridor is the most critical piece of information to do your grading design, and the most critical piece of information to do your servicing design. And you'll see why when we get to it. But you can't build a corridor without a plan, your alignment, your profile, the vertical design, and a cross-section, which I'll discuss next week. I don't want to put any more on you today. Any questions about this procedure? It doesn't take long to do. It took me longer to explain what you're doing and why than actually how to do it. Okay? So I hope you understood what I was talking about, and then you can review the video to see. There is no PDF for what I just did. Okay? And all the hand calculations we did, right? This is board work. I would have done this on the board. I would have asked you to stop looking at your computer and watch what I'm going to do in terms of the engineering design. The minimum slope. How did I get this 1.5? How did I get this 1.25? Those calculations. Review the video. Okay? There's no PDFs for anything I did in class today. The points in the plan, you can delete them. There's 2 schools of thought. You can delete them. And then again, if you delete them, if I delete them in plan, if I delete these 2 points in the plan, they disappear in the profile, which is fine. So you can delete them, or you can put them on a layer and freeze them. They shouldn't be visible. They're a technique, a tool for you to draw this profile, right? So in the profile, you don't want to see them. So if you don't delete them from the plan view, you certainly want to delete them from the profile view. Right? And then the mystery gets even bigger, right? Why are those PVI stations and elevations where they are? Right? So when you look at this, if you didn't come to today's class, right? Why is that station elevation there? Why is this one here and not over here? Right? Or why is that not over here? And why are the slopes what they are? Okay? And that was today's discussion. The station value is dictated by the plan location of those key points, and then the profile slopes are coming from minimum and minimum to guaranteed gutter slopes here and here. And then this little trick at the intersection, right, where you have a little bit of a low point, right, come down half, come up at 0.5%, so that you can avoid using the vertical curve. Most of what you do is in the atypical things. What happens on your standard right-of-way, right, what happens in here is very quick. What happens between here and here is very quick. Just like you spending time in the crescent and the cul-de-sac and the intersection in your plan view, you're going to spend time in your profile at the intersection, at the elbow, and at the cul-de-sac. What happens between those atypical things is pretty quick, pretty standard stuff, right? It's when you get stuff that are atypical in width that you have to spend a little more time on. So Stephen, the answer to your question is I don't want to see those points, so either delete them or freeze them. They're only there for the purpose of the technique. That's the short answer. Any other questions? Okay, so that's it for today. Please review the video. There's only 25 of you in class. If you know your classmates that aren't here, the other 15, tell them to review the video. It should be available late today or tomorrow. And it explains everything again. It goes through the calculation, and then it shows you the civil 3D technique. The civil 3D part of this lecture is very, very short and quick. The explanation of the design is really the focus of today's class. Okay? Once you know what the design should be, then you can input it pretty quick. So to get to this stage before next week is going to be fast. Are you going to update our grade and grades? Yeah, I'll for assignment 1, right, Sumitra? I'll post it, right? But you all have your email results, right? Everybody knows how you did on your assignment, but I will put it on the gradebook. Yeah, thanks for the reminder. I'm trying to get that done today. Okay, that's it for today. I'll see you next week. You too, Michael. Thank you.